Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Welcome to Lesson 21, Solution Sets to Inequalities with two variables. So classwork exercises 1 and 2. This means, an exercise means, do it on your own, check it out, see what you came up with, and then check back with the video. So pause here, do problem 1A, and then unpause the video and see if you got the correct answers. So assuming now that you have paused, here we go. Circle each ordered pair xy that is a solution to the equation 4x minus y is less than or equal to 10. So anything when we substitute in these points that is less than or equal to 10 is a solution point. Okay, so if 3 is x, 4 times 3 is 12, 2 is y, 12 minus 2 is 10, 10 is equal to 10, so 10 is less than or equal to 10. That is a solution. Okay, 2, 3, 4 times 2 is 8, minus 3 is 5, 5 is less than 10. Negative 1 times 4 is negative 4. Negative 14 plugged in here would be plus 14. Negative 4 plus 14 is 10. 10 is equal to 10, so that is a solution. 0 minus 0 is 0. 0 is less than 10. Plug in 1, you get 4 times 1, which is 4, plus 6. 4 plus 6 is 10. That is a solution. It's equal. 5 times 4 is 20, minus 10 is 10. 10 is equal to 10, that's a solution. 4 times 0 is 0, plus 10 is 10, that is a solution. 10 equals 10. 4 times 3 is 12, minus 4 is 8, 8 is less than 10. 6 times 4 is 24, minus 0 is 24, that is not a solution. And 4 times 4 is 16, plus 1 is 17, is not less than 10. That is not a solution either. So you should have gotten these 8 solutions. These 2 are not. Okay, part B says to plot each solution as a point xy in the coordinate plane. So here we go. I will plot the point 3, 2 is over 3 up 2. This is my first solution right here. And then 2, 3 is over 2 up 3, which is here. And then negative 1, negative 14, that's way off this grid because then it goes down to 10, I believe. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm at negative 1, negative 10. 11, 12, 13, 14 would be about here. 0, 0 is the origin. 1, negative 6. Is right here. 5, 10 over 5. 1, 2, 3, 4, 5. Right up here is 10. So this is the point 5, 10. 0, negative 10 is on the y-axis down here. And finally, over 3, up 1, 2, 3, 4. Okay, so those are all the solutions to the set that they gave us anyway. So B is done. We plotted each solution as a point xy in this coordinate plane where this is my y-axis and this is my x. Should always label those. C says, how would you describe the location of the solutions in the coordinate plane? Okay, so it's kind of hard to answer this question, but I do see that I have a set of points that are along this line, and some of these were equal. So here is a line, and these points were on it, and these are close to it. But I think that if there was more points over this way, they would also be solutions, and any points over here would be not solutions. Who knows? But that's what it looks like without doing more investigation and actually graphing this and setting it in standard form and finding the slope and the y-intercept. Okay, page 2 brings us to problem number 2. And part A says to discover as many additional solutions to the inequality as possible. Organize solutions by plotting each solution as a point xy in the coordinate plane and be prepared to share the strategies used to find the solutions. So if I look at this, so the green dotted line is, I think, my solution border, if you will. And I was noticing that the solutions were ending up on this side because this is a solution and this is and this is, and I cut that off. So there's another one down here. So I'm thinking if I choose solutions over here, so if I choose negative 5, 5, and put a point right there, negative 5 times 4 is negative 20, plus or minus 5 is negative 25. That is less than 10, so this is a solution. So let me put that, negative 5, comma 5. And how about negative 1, negative 1? Well, if I put negative 1 in here, I get negative 4. Negative 1 here would be plus 1. Negative 4 plus 1 is negative 3. That is also less than 10. So the point negative 1, comma negative 1 is a solution. So how about if I pick the point 210? I'm just checking points on this side of the line. 210, well, if I put 2 here, I'd get 8. Minus 10 is negative 2. Negative 2 is less than 10. So that point is also a solution. So I want to justify my system here and check something else. How about if I pick a point over here like 9, 0? 9 times 4 is 36. Minus 0 is 36. 36 is not less than 10, so this is not a solution. So it does appear that my answers are on the left side of this line. So let's just do one more. And how about the point 0, negative 5? Plug in 0 here, I get 0. Minus negative 5 is plus 5. 5 is less than or equal to 10. That is a solution. So 0, comma negative 5 is also a solution. So those are just a few. How many solutions are there? There are infinite solutions. Any point over here, decimal fraction, and we can go all the way to the left forever and ever and all the way up forever and ever, and there will be a solution. All right, part B says graph the line y equals 4x minus 10. So now if I graph that line, so I'm going to get rid of this because I just copied it over from the previous page. Let's just get rid of that and erase these points. Okay, so now it says to graph the line y equals 4x minus 10. What do we notice about the solution to the inequality 4x minus y is less than or equal to 10 and the graph of the line y equals 4x minus 10? Okay, so 4x minus 10 has a y-intercept of negative 10. So if I plot that, it's right here, negative 10. And the slope of 4 means go up 1, 2, 3, 4 over 1. Rise 4 over 1, 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. And I'm just going to do this until I get to the top. 4 over 1, and 1, 2, 3, 4 over 1. So there is the line. So let me draw that in. And make it blue. So it is a line going through all these points right here. It's not quite on point. Haha. Alright, so there we go. It is going through all these points. And obviously it would continue, so that should have arrows at each end. Okay, so there is the line. Y equals 4x minus 10. And what do we notice about the solution to the inequalities? 4x minus y is less than or equal to 10. And the graph? Well, the solutions were either on that line or to the left of it. Or I should say, above it. Okay, so there it is. And part C says solve the inequality for y. So the inequality was right here. 4x minus y is less than or equal to 10. So solving for y, if I have 4x minus y less than or equal to 10, to get y by itself, I subtract 4x from both sides. And when I do that, these cancel and I get negative y less than or equal to negative 4x plus 10. Now this is a negative y, so if I multiply everything by negative 1 or divide everything by negative 1, it changes the sign of everything, so we get y And remember, if you multiply or divide by negative, inequalities flip. Do not forget that step. Negative 4x becomes positive, and a positive 10 becomes negative. So my solution is y is greater than or equal to 4x minus 10. So here's my line. Greater than or equal to is above or on. So anything this way is greater than that blue line. So it says complete the following sentence. If an ordered pair is a solution to 4x minus y is less than or equal to 10, then it will be located blank the line y equals 4x minus 10. Okay? So the answer would be located on or above. Or you could say on or to the left. Either one. But I'd prefer above because we're thinking up, down when we're talking about y. Y is your vertical change. And then it says to explain how you arrived at your conclusion. Okay, so one thing you could say is, I observed that all the points were on one side of the line. And then I tested some points on the other side of the line and found that none of the points I tested from that side of the line were solutions to the inequality. Okay. Okay, page 3 brings us to the example. The solution to x plus y equals 20 is shown on the graph below. X plus y equals 20. So we have an equation. If I moved x to the other side, it would be y equals negative x plus 20. Y-intercept of 20, slope of negative 1. So if you go down 10 over 10 is the same as down 1 over 1. So this is the equation of this this is the graph to this equation. Part A says graph the solution to x plus y is less than or equal to 20. So it's the same as this. So I would start by drawing that same line. Okay, but now we're doing less than or equal to. So we want to be below this line. So then I will shade. Okay, so here's the line, and we wanted below it, so I shaded below. C says to graph the solution to x plus y is less than 20. So notice here we do not have an equal sign. Less than only, well, that would be a dashed line. So let's draw a dashed line. And choose this, choose this, choose this, and thinner though. This with this thickness. How about that? So we still have the same equation. Okay, but it's going to be there. Okay, so there's the line segment, or line. Y is less than negative x plus 20 if I move the x over. And it's still less than, so we're going to shade below. So I'm just going to do this and put my shading down like so. So it should be a dashed line shaded below. Okay, part B says graph the solution to x plus y is greater than or equal to 20. So again, we're going to be a solid line because it's got an equal sign. So I'll just put that there now. And now I need to shade above because it's greater than. Okay, so this one has a solid line shaded above because of the greater than symbol. So now it says graph the solution to x plus y is greater than 20. So it would look like this. The shading is in the same location because it's still greater than, but the equal sign is not there, so I need this line to be dashed. That's the only difference between the two. Okay, so here's what it would look like. Dashed line shaded above. Okay, page 4 brings us to exercises 3 through 5. And we start off by using a separate sheet of graph paper, plot the solution sets to the following equations and inequalities. So you should have graph paper and it should have a coordinate plane on it to do these problems. And in order to do these, I'm going to use a GeoGebra graphing calculator just to make it nice and neat, but I'm going to go through the process as if I were graphing it on a piece of paper. So I'm going to start with A. And it says x minus y equals 10. Okay. Okay, so I made room for myself now, so now we're going to do x minus y equals 10. And in order to graph this, I want to put this in y equals mx plus b, or standard form. So I'm going to add, I should say subtract x from both sides. So when I do that, these x's cancel, and I get negative y equals negative x plus 10. And multiply everything by negative 1 will change all the signs. Y equals x minus 10. Okay, so if I plug in 0, or I could also have done that, if I plugged in 0, then y is negative 10. So if I picked a point 0, 0 minus 10 is negative 10. So it would be 0 way down off the graph. So let's continue with larger values. And I could also, I could actually zoom out and move this over here. That's better. So 0, negative 10 would be a point right here. Okay, and then I now know my y-intercept, and then it's just a lot quicker now to just plug in numbers. So now now I'm looking at this here, if I plug in a 1 now, 1 minus 10 is negative 9, okay, and 2 minus 10 is negative 8, so since I zoomed out, these are by 2's, 2, negative 8 would be here, and let's go by 2, so plug in 4, 4 minus 10 is negative 6, and 6 minus 10 is negative 4, and 8 minus 10 is negative 2, and 10 minus 10 is 0. So there's my line segment there. So now if I go to the calculator, I can check it, and I can plug in x minus 10. Okay, so there it is. So that's what your graph should look like. Since it's equals, it's just the line itself, and we're done. Okay, so now I'll do B. B is x minus y is less than 10, x minus y less than 10. So let's get this again, subtract x from both sides, solving for y, and I get negative y is less than negative x plus 10. Multiply everything by negative 1 would change this to positive y. It would change this to greater than. Don't forget that. Negative x would become positive x, and 10 would become negative 10 or minus 10. Now I have y is greater than x minus 10. So if I plot points now, my y-intercept is negative 10. And then if I plug in values, it says y is greater than x minus 10. Plug in 2, I get negative 8. So it's that same segment, 4, negative 6, 6, negative 4, 8, negative 2, and 10. Oops, I don't want to drop that point there. Switch to arrow. Where's that move? There it is. Okay, so let's now move this to there. Now let's delete it so I can drop it right in where I want it. And 10, 0. Alright, so there it's the same line that we had before, and again this continues forever both directions, but now I want y is greater than x minus 10. So now if I go back to my calculator and put that in, y greater than x minus 10. Enter. Okay, so there it is. It is a line dashed. Notice it made it a dashed line because there's no equal sign, and it's shaded above. Okay, again we have C now. Y is greater than x minus 10. It's already in standard form. I know my y-intercept is negative 10. Let's zoom out so I can get that, and switch to move, and center that like so. Point. Negative 10 is my y-intercept. Alright, so 0, negative 10. 0, plug in 0, I get negative 10. Plug in 2, and again I get that negative 8. 4, negative 6. Plug in 6 minus 10 is negative 4. 8 minus 10 is negative 2, and 10 minus 10 is 0. So it's that same border, if you will, line segment or line. And now we're graphing above y is greater than. So if I put that in the calculator now and I put y is greater than x minus 10, then it shades it above dash point. So basically this was the same as b. Okay. Okay, so now I'm doing D. D is y is greater than or equal to x. Well, think of this, y equals m, m is 1, x plus b, b is 0, so I have the point 0, 0. So if I plot that point, if y is 0, it equals 0, that's true. And then if y is 1, or x is 1, then y is 1, and if x is 2, y is 2, and if x is 4, y is 4, because of this equal sign. So no matter what I plug in for x, y's got to be the same. 7 equals 7, 6 equals 6, 8 equals 8, 10 equals 10, and so on. So I'm going to just put points here, -4, -4, -6, -6, and so on, and it just continues. All right, so it's an equation with an equal sign. So this line is solid, and greater than means to shade above. So if I go back to my calculator and input this, and I say y greater than or equal to x, and there it is. Solid line on where my points are, shaded above. Okay, now we're on to E. X greater than or equal to y. Again, we have x equals y. All right, so we're going to get that same thing. When does x equal y? Well, when they're the same. When x is 0, y is 0, x is 2, y is 2, 4, 4, 6, 6, 8, 8, -2, 2. Oops. Can I undo that or move it? I'll move it. I didn't snap. There we go. And -4, -4, -6, -6, -8, -8, -10 equals -10. Now it's x is greater than or equal to y. Well, if you're more comfortable graphing something, it's a lot easier to see what's going to happen if y is on the left. So if I just flip all of this and I put y over here, and then my equation, my greater than symbol is always facing the x, so x is greater than or equal to y is the same as y is less than or equal to x. And now I have it in y equals form. And now I can put it in my calculator by graphing. So if I graph this and I put y less than or equal to x, the equal sign gives me a solid line here, less than shades below. Okay, that brings us to F. Y equals 5. Well, that means if x is 0, y is 5. Okay, let me zoom in a little so I can see the 5. Because this is right now, it's skipping 5 because it's going by increments of 2. So there's my 5. All right, so if I graph, if x is 0, y is 5. If x is 1, y is 5. If x is 2, y is 5. When it says y equals 5, it just means no matter what x is, y is always 5. Constantly 5. It's a constant function. Every time I choose an x, y is always 5. So now if I go to, and it says y equals 5, so if I graph that, and I do y equals 5, there's my line. All those points are on it. It's the equation of a line, so there's no shading. It's not an inequality. Part G, y is less than 5. Okay, again, when x is any number, y is going to be 5. So 0, 5. Plot a point, 0, 5, 1, 5, 2, 5, -1, 5, -2, 5. Less than means that is going to be a dashed line. Less than means it's going to be shaded below. There's no equal sign, shaded below. So I go to my calculator and input y less than 5. So it's a dashed line shaded below. Okay, we're on to H. X. Why is that red? X. Oh, greater than or equal to 5. Here, let's clean that up. I don't know why I tried to change the color and then I'm going back to red. Alright, try that again. X greater than or equal to 5. That means no matter what y is, x is always 5. So if y is 0, x is 5. If y is 1, x is 5. If y is 2, x is 5. If y is negative 1, x is 5. X is always 5. There's an equal sign, so this will be a solid line. X greater than 5 means to the right. So if I go back to my graphing calculator and type in x greater than or equal to 5, and it puts it over here, shaded to the right. Solid line, shaded to the right. So I could also pan this over to show you that it just goes on forever. Okay, there are no solutions to the left of this. It's always to the right. Okay, I might be a little tricky. So it says y is not equal to 1. Alright, this is just weird. You saw me click on that and then it's not purple. Okay, y is not equal to 1. Y is 1 equals 1 is right here. Well, if it's not equal to 1, then I want everything except what would be here on this line, y equals 1. So y is not equal to 1 is the same as saying y is greater than 1 or y is less than 1. So it's everything greater than 1, everything less than 1, but not 1. So if I graph that, y is less than 1, it's a dashed line shaded below. And then if I return and do another one and do the y is greater than 1, so it's everything shaded with this dashed line going through, meaning any point on this line would not be a solution, but everywhere else in the universe would. So that's the graph of that. Okay, we're on the J. J. X equals 0. Okay, so that means no matter what y is, x is 0. So plot points. If y is 0, x is 0. If y is 1, x is 0. If y is 2, x is 0. If y is negative 1, x is 0. If y is negative 7, x is 0. Doesn't matter what y is, x is always 0. So if I graph that, x equals 0 is that vertical line. It's the y-axis. X equals 0. Okay, part K. X is greater than 0. Alright, so we just had the line segment. We just had it. If x equals 0, where are we? We are on the y-axis. So no matter what y is, x is 0. But I want greater than. So that would be shaded to the right. And this is not a solid line because there's no equal sign. So if I graph that, I want x greater than 0. Dashed line, shaded to the right. Okay, on to L. Y is less than 0. Okay, so I want y to always equal 0. So always change this inequality to 0 to find your border, if you will. Y equals 0 is when y is always 0. So when x is 1, y is 0. X is 2, y is 0. X is negative 4, y is 0. X is negative 2, y is 0. Alright, but now it's less than without an equal sign, so there should be a dashed line going through these points, and the less than is shaded below. So if I go to my calculator and do y less than 0, It's a dashed line going through those points, as I said, and shaded below. Okay, we're on to M. M is not linear. It says x squared minus y equals 0. Okay, so I could put some points in here, or I could just solve this and do a table. So let's just plug in 0 for x squared. So if I have the point 0, x is 0, 0 squared is 0. So if this is 0, what do I subtract from 0 to get 0? That would also be 0, so I have the origin. So then if I plot a point at the origin, 0, 0, and then if I come back here and put a 1, 1 squared is 1. 1 minus 1 is 0, so I have the point 1, 1. So I go back over here and plot 1, 1. Okay, and if I continue this without doing any changes, I'm going to do it a different way in a minute. If I plug in a 2, 2 squared is 4. Minus 4 is 0. So y has to be 4 when x is 2. So I go over to the point 2, comma 4. And that's right there. Okay, now I'm going to go the other way. I'm going to plug in a negative number for x. Negative 1 squared is 1. 1 minus 1 is 0. So negative 1, 1 is a point. And then if I plug in negative 2, negative 2 squared is 4. Minus 4, y has to be 4 to get that back to 0. So negative 2 and up to 4. Okay, so as you can see, it is a parabola because it's x squared. And so if I rearrange this and added or subtracted x squared from both sides, so let's do that. Let me move this over a little bit. Alright, so I'm going to subtract x squared from both sides, getting y on the left. So y, negative y, equals negative x squared. Multiply everything by negative 1 gives me y equals x squared. So if I go to my calculator and input x squared, there's the parabola going through those points. It was an equal sign, so there's no shading. It is just these function values itself that are solutions to this. Okay, now I have the equation x squared plus y squared is greater than or equal to 0. Well, x squared plus y squared greater than or equal to 0 is in the same form as x plus h squared plus x minus h squared. Okay, x minus h squared plus the quantity y minus k squared equals r squared is the equation of a circle, where r is the radius. So in our case, we have a radius of 0 and the center of 0, 0, because the h and the k are not there. So x minus h is x, y minus k, which would be y minus 0, is y. So this is a circle centered at the origin with a radius of 0. Well, what is a circle with a radius of 0? It's a point. So in other words, the solution to this is everywhere, because this says greater than, everywhere on the graph except the origin. Okay, so let me see what happens if I put that in my calculator. X squared plus y squared greater than 0. So there's a solution. It's everything except the origin. 0, if I plugged in 0, 0, 0 plus 0 is not greater than 0. That is not a solution, but everywhere else is. Okay, so now we have x times y is less than or equal to 0. In order for me to get solved for y here, I would have to divide both sides by x, because that means x times y. So if I divide both sides by x, that would cancel, and I get y is less than or equal to 0 divided by anything is 0, except y cannot equal 0. If I were looking at it in this sense. Not y, I'm sorry, x could not equal 0. Okay, so what's going to happen here? I really don't want to do it this way because, well, let's see what can happen. If I divided both sides by x, I have y is less than or equal to 0 when x is not 0. If x is 0, it's undefined if I do it this way. But if I just pick some values, so let's think of it without doing any adjustments to this. If I say x, y equals, there's less than or equal to 0, I'm sorry, less than or equal to 0. I want this to be negative. Well, what does that mean? Well, either x is negative, that would make this negative. A negative times a positive is negative, or y could be negative. So I could have an equation x times a negative y is less than or equal to 0. Okay, so either x is negative or y is negative. Let me make that a little neater. Okay, so if x is negative, y has to be 0 to make that 0. And if y is negative, x has to be 0 to make this 0. All right, so if I plot some points, what if x was 5? Well, in order for x to be 5, y would have to be 0 or less. So if x was 5, okay, so let's just pick some points. If x was 5, and I'm using this green, I'm using this over here. If x is 5, y could be 0. If x was 5, y would have to be negative, like negative 1. 5 times negative 1 is negative 5, that's less than 0. So if x is positive, y has to be 0 or negative. Okay, if x was 2, same thing. Y would have to be a negative number, negative 3, how about? So if I have the point 5, 0, okay, if I have the point 5, 0, actually let me delete that. Let me go with, yeah, I can do that. Let me just zoom in a little. So there's a 5, okay, move. All right, there we go. So if I put a point 5, 0, it's right here. If I put the point 5, negative 1, it's right here. If I put the point 2, negative 3, it's right here. So any value where x is positive and y is negative would give me a negative number or 0 if it's on the x-axis. Same goes with if I go over to the other side. If x is positive, like 5, again, if x is 5 and y is negative 3, 5, negative 3 would be here. So it's all these points down here, but if I plugged in a point up here, 3, 1, for example, 3 times 1 is 3, 3 is not less than 0. So I don't want, oops, undo that. I do not want anything in the first quadrant. So I'm on the x-axis or in the fourth quadrant so far. But what if x was negative? So now if I pick a point, negative 4. Well, if negative 4 times something has to be less than 0, y's got to be positive, because a negative times a positive is negative. So if I plug in a 1, negative 4 times 1 is negative 4, that's less than 0. So negative 4, 1 is right here. And if I plugged in two negatives, like negative 4 comma negative 3, over 4 down 3 is right here. Well, negative 4 times negative 3 is positive 12, and that's not less than 0. So there's no solutions down here or up here. So it looks like every solution is in quadrant 2 and quadrant 4, as long as we are on the x or y axes, because x and y can also be 0. Okay, so if I graph that, that would look like x times y less than or equal to 0. And there it is. All the values in the second and fourth quadrant with solid lines for my x-axis and y-axis. Okay. Okay, now finally answering the question for 3, it says, which of the inequalities in this exercise are linear inequalities? What's this? Okay, so linear is anything that has to do with a y and an x in the first degree. So the inequalities that are linear are A, B, C, D, E, F, G, H, I. X equals 0. J, yes. K, L. So anything with X or Y in the first degree. So I'll just do this. Those are linear. X squared does not make it linear. X squared, Y squared, not linear. X times Y is not linear. Okay, moving on. Here's the definition for half plane. A half plane is the graph of a solution set in the Cartesian coordinate plane of an inequality in 2 real number variables that is linear and strict. 4. Describe in words the half plane that is the solution to each inequality. So y is greater than or equal to 0. The half plane would be lying above the x-axis because y equals 0 is the x-axis and includes the x-axis itself. Okay? X is less than -5. Okay, well, the x equals is a vertical line, so it would be a dashed line on -5, vertical, and everything to the left. Okay, so the half plane to the left of the vertical line, x is equal to -5, not including the line x equals -5. Okay, part C, y is greater than or equal to 2x minus 5. Okay, that's a solid line, including the equation 2x minus 5, and it's going to be shaded above. Okay, so the line y equals 2x minus 5 and the half plane lying above it. So we're including the line and above. Y is less than 2x minus 5 would be the half plane below the line 2x minus 5, but not including it. Okay, half plane lying below the line. Okay, page 5 brings us to problem number 5, and it says, graph the solution set to x is less than -5, reading it as an inequality in one variable, and describe the solution set in words. Then, blah, blah, blah. So let's just do this part first. When it says in one variable, we're talking about one-dimensional or a line, or should I say a number line. So the x-axis is one variable. There's no y, so there's no height. So I don't have the 0.5 comma 3, I just have the 0.5, and I'm on the x-axis, so it's a number line. So we're going to plot this number line. Okay, so here's a number line from -10 to 10. And it says x is less than -5. So here's -5. So less than that value, I want to put an open circle here. I don't want to include that. But -6 is less than -5. -5.5 is less than -5. So it's every fraction decimal that is to the left of -5. So the answer to this would be this shaded over here and going forever. So that would be an inequality in one variable graphed. In words, it would say, read in one variable. All real numbers less than -5, the graph will have an open circle at the endpoint -5 and extend as a ray to the left of -5 on the number line, which is what I have graphed. Okay, now let's move on to, then it says to graph the solution set the same, this time reading it as an inequality in two variables. So now we're going to do it in two variables and describe the solution set in words. Okay, so x is less than -5. So -1, 2, 3, 4, 5. So 0, -5 is right here. 2, -5 is here. 4, -5. I'm sorry. Start over. -5, 0, -5, 2, -5, 4, -5, 10, -5, -10, -5, -5. And so in other words, when x is less than -5, it means the line, vertical line at x equals -5, but it's not going to be a solid line. It is going to be dashed. So we'll choose dashed, and let's use the same color, red. So it would be a dashed line. Oops. Might help if I chose the line segment, dashed, and red. And so it's right there. But it says less than. So I want this region over here shaded. So to shade that, okay, so here's what it would look like. A dashed line at -5, shaded to the left. How would I put that into words? So I'd say read in two variables, all ordered pairs x, y, such that x is less than -5. So it doesn't matter what y is, but x has to be less than -5. The graph will be a dashed vertical line through the line x equals -5, and all points to the left of the line will be shaded. Okay, so page 6 brings us to the end of lesson 21. Review the lesson summary and go do your problem set.